Okay, so here we have an example of the attendee interface. In the top right-hand corner, you should see something like this. Clicking on the arrows on the Grab tab opens and closes the control panel. The audio pane provides audio information, and you can choose to join the audio through two options. The first is to join audio through your computer. Select Use Mic and Speakers. Next, click Audio Setup to select your computer speaker or headset device. You can also join audio through your telephone. Select Use Telephone, dial the number listed, enter the access code, and also the audio PIN when prompted. During the presentation, you have the ability to send questions to our webinar staff. Simply type your question in the questions pane and click Send. At the end of the presentation, we will do a question and answer session to answer as many questions as we have time for. There is also an option of asking questions directly to the presenter. To do this, raise your hand, which is located on the control panel, and when we get through the list, we will then unmute your microphone and you can ask the questions directly. If you prefer to keep your control panel open during the presentation, click on View and then uncheck Auto Hide the Control Panel. I will now pass you to Mr. Ray Pavry, Managing Director of Sustainergy.
Thanks, Georgia, and thanks, Tom, for doing the presentation. Could I start off by welcoming everyone to this second webinar organized by Find All Electrical Jobs. Our first one was on smart grids, and we certainly have had excellent participation for that, so this is in continuation with that. Just as a quick background, Find All Electrical Jobs is a specialist jobs board specifically for electrical talent, with jobs sourced from direct companies only. That means no agency jobs. Further information can be found from the website www.findallaelectricaljobs.com.au. Today's webinar is on plant asset management systems. It's presented by Tom Rolton, who has 36 years of experience in process automation and control. 10 years of that have been in a commissioning marketing environment. 21 of those have been with Emerson Process Management. Tom's current position is Business Development Manager, Plant Web and Wireless Networks. I've heard Tom present at several IICA and other events, and I've certainly found his presentation extremely useful and extremely lively. Please join me in welcoming Tom Rolton.
I hope we're online now. I'm
yes,
going to be speaking to. Say again?
So you're online now.
Thank you for that. Just switch screens. Thank you for joining me around the country today. I'm speaking to you from Melbourne. We're going to talk about plant asset management and the business value in using 2010 technology. There's been some very exciting things happening in the technology, and particularly this year with standards, and I'll speak a little bit more about those later in the presentation. Today's business environment means that we often need to make decisions in a wide range of areas. You know, where we would want to invest that money and how we would get a return on that. Just looking at some of the areas that you may invest, that you would like to improve, in areas like the quality, the throughput, and the availability. Maybe we need to increase the performance in the area of waste and rework. Look at the operational and maintenance aspects, the safety, health and environment, or utilities. These are 7 buckets. I'm sure that for each of you today, at least one of these, if not most of them, have a specific interest for you. What we would like to do is show you how you can improve the performance in those areas and get a good return on your investment. There are many critical business challenges today in many areas: reliability, finance, safety and the environment, efficiency and throughput, personnel, just to name a few. Today we'll just have a look at the reliability. We all know today that any one of these particular areas, the challenges are linked. One cause has a roll-on to many others. So why do most of these still remain unsolved today? Areas of reliability, efficiency, as we talked about. Whether it's the environment, there's a lot more pressure to maintain environmental standards on site. Safety of the individuals and safety of the plant in areas of overspill and things like that. We'll have a quick look at this model and just see where things go. So lack of information is often the reason that we find it difficult to be able to improve these things. Things happen, we don't know that they're going to happen, so there's no predictive nature to it. What we would like to look at in this session is how do we actually find out more about what's going on site? Have we got all the information to achieve the best results? Have we just got some of the information, or do we have no information at all? Today we'll focus a little on the technology, communications. Wireless, of course, is not new, but there have been exciting changes, and particularly, as I mentioned earlier, in the standards that we'll come to later. Wireless is able to reduce the capital invested and cut implementation times dramatically, as we see the numbers here. There are online calculation facilities that are available, and if you contact Sustain Energy regarding these, we'll be happy to pass on links that you can get to some very valuable information related to these subjects. Wireless solutions for the plant can be from simple things like making tank measurements, looking at pumps, heaters, and do I have a problem with a particular pump? Have I got cavitation on that pump that's causing significant erosion in pipes or on the impellers of plant equipment? Performance of heat exchangers, emissions control, valve diagnostics, even things like safety showers. In Australia, there are many showers on almost every single production site today. However, most of those showers have no monitoring at all. And we'll talk a little bit about that as one of the specific applications as we go forward. On top of that, of course, things like mobile workers, having a PC, a cuff book that's capable to go out into the field, or tracking people to make sure that they're safe. Video for security. So many things today, of course, we take for granted, have been done in the past on a hardwired network. Today there are very good standards to incorporate even these high-level applications. By monitoring equipment that in the past has not been monitored, it may be something as simple as a motor. We'll have a look at an example of one of those later in the session as well. Electric motors. Today, as they have for many years, temperature sensors even in the windings of the electric motors. Do we connect up those sensors? So often those sensors are left unconnected, and therefore valuable information that can provide safety on the plant, better return on the investment, and that we don't lose the pump or the fan or the motor that's there. And at the end of the day, it's not the cost of the pump or the fan or the motor. Often you go to any workshop and out the back there's a pile of these things. The real cost is the downtime and the other safety issues. As we see, there are many applications on this list, and we'll look at a few of those as we go further through. What's necessary as we make these measurements is that we can then tie it all together and integrate it into a management system. And today, of course, there is some very good software from a number of manufacturers that will allow us to do this in a very elegant and seamless manner. What we'll do now is just have a look at some of the applications, and I'll just quickly step through these. We started a little late, so I'm going to get through them very quickly, but if you have a look, it only took 3 hours to install the instruments and configure and establish the IP network and make the Ethernet connection ready at the control room. These are qualified business results from a wide range of customers. If people would like further information on this, again, Sustain Energy can provide you with specific details. Thank you. The previous tank overfill cost us $1.5 million. These sorts of situations are not things that just happen internationally. Even in the state of Victoria, where I'm speaking from today, these types of things do happen on a regular basis, far more often than what we would wish. And again, measuring and knowing what's happening in the field can prevent a lot of these unforeseen situations. However, the cost of installation in the past of cabling, take a tank farm, is often just too expensive. Cutting into the bunions that have been specially compressed with clay or whatever it happens to be, it's very, very expensive to run cables in a lot of these environments. The installation was very simple in this situation. $200,000 per tank for repairs. Installing wireless instruments and providing a high level of reliability. Again, I will flip through these quickly, and if you want to have further details, please inquire. You'd be most welcome. Improving efficiency on heat exchangers, often not having any measurement or insufficient measurements, may cause losses in dollars, production, and all of the roll-on effects that come from that. Again, wireless is an enabling technology that makes what was very difficult in the past a very simple solution today. Improvements in major refineries. Improvements in compressor maintenance. Things like vibration in the past. Today, fitting a simple vibration transmitter is a matter of just putting a simple clamp on a 2-inch pipe and a magnetic coupling, if it's only temporary, directly to the motor. Within 5 minutes, you have a measurement fully operational and ready to use. This was just not possible in the wired world. Knowing what's happening with your devices from a predictive manner, we'll look at 2 or 3 applications specifically with those and how this technology works. Compared to using conventional networks. Again, in some instances, customers are saving up to 90%. If you've got to trench or put cable trays in, the infrastructure to do these sorts of things can be very, very expensive. People talk about plug and play. Here's an example of a customer. They were told that it would plug and play. He laughed. 5 minutes after installing it, the system was up and running. Even in Australia, with some of the large mining companies, we would install them on equipment like conveyors, where they require an urgent measurement of vibration or other difficulties with equipment. Maybe a large bearing is starting to fail. Being able to install the equipment and have a permanent measurement for the period of time that you wish, it's a very enabling technology. Increasing safety in the plant. Going up a stack or to some location to look at a valve or an instrument on a beautiful sunny day is a very easy thing, but as many of us know, most of us know, at 2 o'clock in the morning in a thunderstorm when it's pouring down with rain, what is a safe place on one day is not a safe place on another. Getting access to that information can be very important. One of the interesting surveys from the ISA, most of us know of the ISA, a well-recognised organisation, they say that 63% of times when a person's called out to the field to look at problems with instruments and valves, in 63% of the case, there's nothing wrong with that device, but we still need to go out there or shut the plant down until we can get out there. Being able to analyse that remotely has huge benefits, not just from a cost point of view, but also from a safety point of view. Here, BP, talking about the refinery of the future. One of the companies who's embraced this technology throughout the world, and in Australia and New Zealand, embracing this technology throughout tank farms. And we'll talk a little bit about the application there towards the end of the presentation. Here they used the machinery health transmitter, or as we call it, the wireless vibration transmitter, to detect particular faults with pumps and fans and motors, as we spoke about before. Being able to detect a motor bearing well in advance. Typically, bearings don't just fail instantaneously. We wouldn't be allowed to drive motor cars around the street if this was the case. Having a device where we can detect these things early and then be able to safely shut them down, or shut them down at a time that suits us when we have the ability to have a shut, can have a major impact on the plant's performance. In Australia and New Zealand, we have this technology being adopted right across the industries, from the oil and gas, mining, petrochemicals, food, a large number of installations of this new White-Hart technology, which is the new IEC standard, and we'll speak briefly about that. Integrating the asset management information can have a great deal of value. Again, some case studies here. Chevron going from 94.4% to 99% efficiency on the valves, the availability of the valve. These sorts of performance numbers, most people understand that these have a huge impact on the ultimate performance of the plant. Maybe it's saving near $1 million a year, or having an 80% increase. The standard that I've spoken about a couple of times is a very exciting thing for the industry as a whole, whether we're manufacturers or users of equipment. 8 weeks ago, the IEC voted on a new standard for wireless communication for this sort of application. And today we now have the IEC 62591 standard. The vote was unanimous to give us this new international standard. What value is this? Well, we know that the technology is going to be in the market for a long period of time. We know that now a wide range of manufacturers can start manufacturing equipment to that standard. Why to the standard? That gives us the interoperability. So if you've got a particular device and you have a wireless gateway, you know that if they're both built to that standard and tested, you'll get the interoperability that's required, the reliability, the security, and the ease of use. All of these things are incorporated in this standard. It's not just a physical layer communication standard. It covers right through to the recommendations of the way that faceplates are presented to the end user. It's a very exciting new technology for us. This wireless can have a major impact, as we talked about before, in reducing the capital employed and cutting the implementation time here by more than 75%. As I mentioned before, being able to go out and take a device out into the field, install it onto a 2-inch pipe bracket that's doing up 2 nuts fundamentally, and connecting the sensor, whether it be magnetic for a motor or a simple impulse line, dramatically reduces the time to get that measurement up and running. Not just from the cost point of view, but also meaning that that measurement's in play and able to be used to keep the plant running. Very quickly we'll look at some ways of achieving the plant connections. That's a very scalable architecture. We could just start with a few instruments or start with a backhaul system. When you put a gateway into a situation on a site, we then start to make the plant wireless ready, and I'll give you a few examples of that now. We may have a plant, maybe it's a particular device, might be a cat cracker, for instance, in a refinery or a piece of equipment. We put the instruments physically mounted into locations that are necessary. That creates, I guess, what we call today a wireless cloud. Within that cloud, you have this add-at-will capability. The add-at-will capability means that you can go out, install the instrument in that cloud with the full confidence that the devices will operate and you'll be able to use that measurement straight away. We, of course, then have a number of those clouds around a larger plant, and then interconnect those clouds together, again using an industry standard, to what we call backhaul that data often to a central location. That may be, if it's for valves, it would go to the valve supervisor. If it's for instruments, it may go to the instrument supervisor. Or if it's data of a physical measurement, it would want to go back to the operators in the control room. That information, of course, can be routed very simply to the locations that are necessary. Thank you. Looking at some of the technologies that are around today, there are things like conductivity, pH, multiple temperature transmitters. You might say if you've got a motor, you want to measure numerous temperatures in a single location, maybe flow, pressure or temperature, maybe your valves that you're interested in. The thumb we see on the right-hand side in the new products that were released in 2010, the smart thumb adapter, what that does is it connects to conventional instruments. 95% of smart instruments, that is instruments that have the communication protocol on them, the majority do and have done for the last 1.5 decades, that's the communication that your handheld talks to. By adding a thumb to that, it makes a conventional instrument that's hooked on a 4 to 20 milliamp, whether it's a transmitter sending back a 4 to 20 milliamp signal, or whether a valve receiving a 4 to 20 milliamp signal. That digital data has been there for many years, 25 years in total, but typically it's been used in the last 15 years. And it's stranded out in the devices. So that rich, valuable digital data has been unavailable to us to use. Things like these adapters, the smart wireless thumb adapter, allows us to seamlessly integrate all of that information back to the device. It may be a simple pressure transmitter. It may be a simple level transmitter, like you see the vibration fork down the bottom right-hand corner. Many, many devices are available today, and as I mentioned, many other manufacturers are starting with this technology. There are now over 11 other manufacturers and manufacturing to this new WiHeart standard, the Wireless Heart standard. Applications, very simply, it may be something as simple as the safety shower as we talked about earlier. The safety shower goes often, it's unseen on the site and there's no measurement. We've got water there for the person, but we don't know whether he's in trouble or not. It may be a simple switch on a high level of a tank. Getting access to that information before wasn't the cost of the device itself, but often the cabling costs associated with that. The thumb may be connected to simple valves, as we mentioned before, or a straightforward pressure transmitter. We're going to have a look at a couple of examples of that. Here's the motor that we talked about earlier, connecting up a motor as you see on the right-hand side. That information, just getting, it may be, do I have the temperature of the motor? So these vibration sensors would have also an integrated temperature measurement. If the temperature of that motor goes over temperature, what is the consequence of that? Here's an example of the motor. It's a 250 kilowatt electric motor. As you can see, the shaft here was glowing red hot. This is a burn mark around the faceplate of the face flange of the motor. That's caused the 6-inch, 150 millimetre shaft to bend at nearly 80 degrees. The fan flew off and dug into a wall. Not just the cost of the repairs, but also the safety issues. A simple vibration device or a simple temperature measurement would have avoided this situation. It may be that you've got a hydrocarbon tank, it may be a large storage tank, it may be a bunion that's got a sump in it that you wish to know whether there's been, whether there is oil or other hydrocarbons. In the past that's been very difficult. Again, a simple sensor installed and then wirelessly transmitted back. Again, integrating that information into an asset management package provides a great deal of value. In summary, fewer shutdowns giving us a reduction in these flow-on effects provides a great opportunity today to improve the performance of your plant, see the value, improve the safety, and many other applications. Thank you very much for that. I've tried to get through. We started a few minutes late, and I'll hand over for questions.
Thank you, Tom, for that presentation.
Yes, Tom, I have a question. You spoke about the pressure transmitter, and I just thought the pressure transmitter just measured pressure, but could you give me an example, or what else do you do with a pressure transmitter?
Yes, thank you for the question. The question is, a pressure transmitter, surely we would just want to use it to measure pressure. I guess it's a little like a mobile phone. How many of us today use an analog mobile phone? If we have a pressure transmitter as an analog transmitter, the scenario is quite similar. With an analog phone, you would have only been able to make a phone call. Today, we all use digital phones. It's our phone, of course, but it's also our ability to text, to email, to use a GPS. With a pressure transmitter, how does that relate? Maybe we've got a pressure transmitter that's downstream of a pump, and that pump is cavitating. What's gone wrong with the pump? We may have a leaky seal. If the leaky seal on the pump is on the discharge side, it would squirt out on the ground. And hopefully somebody would see that. But if it's on the suction side of the pump, it's going to suck air in. That air will cause the pump to cavitate. However, what we do know is that that seal's not going to fix itself. That seal's going to continue to leak. It may well go unnoticed until eventually the seal fails and causes the pump to fail. A simple pressure transmitter today can be an advanced diagnostic analyzer on the process to detect that we have a leaky seal on a pump. It may be a pressure transmitter that's maybe on a boiler, where the impulse lines, the little process lines that come from maybe a boiler level or a boiler pressure transmitter measuring the master pressure, those impulse lines get sediment build up in them and they eventually block. We often see when we walk up to a transmitter, there's a differential pressure transmitter and it has two connections to the transmitter and then two lines going down to a little tun dish with blow-off valves in them, and we blow them down. Why do we go to the expense of doing that? Because those lines will block. The problem is that often the operator or the person who does that retires or changes his role, and that particular function goes unnoticed. So today the pressure transmitter not only just measures the pressure, but it measures the quality of that signal coming to the device and will again send an alert to let you know. So there are many applications like this just for a pressure transmitter, and again, if people would like a copy of that, there's some 18, maybe 20 applications of advanced diagnostics. So we're not just talking about diagnostics of the device itself. This is using the instrument as an analyzer to the process. If you would like a copy of that information, please contact Sustain Energy and we'll send you copies of all of these applications. It's very valuable information. Thank you for that question.
Tom, it's Ray Pavry. Just had a question from a strategic level. In terms of the adoption of what you call 2010 technology for plant asset management, namely wireless technology, are companies such as Chevron or Exxon and large companies like that adopting this at a strategic level, or is it still at an opportunistic level?
Very good question. I guess the answer to that is both. Internationally, we see that Chevron are starting to adopt this technology, and particularly from a wireless point of view. There is a publicly available document specifically relating to Chevron and their adoption of these technologies. Again, across the entire oil and gas, I personally have been pleasantly surprised, I guess, to find that near 50% of this technology is being used by the oil and gas industry alone. The second one was being used by ExxonMobil. Again, internationally, they have started to use this technology. I think maybe a little bit more opportunist in that situation rather than strategic as it has been with Chevron, where Chevron invested a very large amount of money in their facilities, and with wireless they have installed on some sites a wireless ready site, so the entire site is what we call this at-will phrase that I used during the presentation. And they believe over the next 4 years, having installed this infrastructure, will provide a saving of some $17 million over having to add those measurements in the old wide world. Thank you.
Okay, Tom, I've just had a question come in through via Sentil. His question is, I'm interested to know about the interface to PLC or HMI from wireless heart instruments.
Thank you for the question. So interfacing this type of data into SCADA and other types of interfaces, be it Cytec or any of the others that are in the market today, I only use that because it was a very innovative Australian product. Yes, we've done numerous interfaces to Cytec and other products in the market or directly to the PLC. There are both Ethernet and serial communications from the gateways, connections like OPC or using the Rockwell Ethernet IP, which is the proprietary protocol, not to be confused with Ethernet TCP, and also serial communications like Modbus. Of course, Modbus can also be done over the Ethernet. So if any of those people would like to make contact directly, I'd be more than happy to provide the specific data. There are some excellent white papers on those particular subjects. Thank you.
Okay, we have another question. I know that valves are very important in industry. You spoke about diagnostics. Can you give me an example of how these diagnostics provide value?
Okay, thank you for that. Diagnostics, let's use the example maybe of a valve. We'd have a situation with a valve where today most process control valves are pneumatically operated. They have what's called a valve positioner on the side of the valve, and many of the attendees today would be very familiar with that and can picture it in their eye. Do we know what the supply air pressure is at the valve? We often measure the pressure at a manifold, but then from the manifold to the valve itself we have a supply air line. Typically it's 15 millimetres, ½ inch. Knowing the pressure of the valve can be very valuable to know whether there's been a problem with the supply air line. It may have been crimped, reducing the air to the valve and therefore making the valve sluggish, or closing it off completely and causing the valve to shut down. We have 500 valves on site. Which valve has caused the problem? Having diagnostics specifically to tell you that you know the pressure. Or it may be, do I have a leak between the controller, the valve positioner itself, and the diaphragm, or is the diaphragm itself leaking? If the valve is not moving, I shouldn't be using any air other than the bleed air in the device itself, and therefore it's a simple function of measuring the airflow that's going to the actuator, and if that's more than what's required for the bleed or for the movement of the valve, again reporting that there is a leak. Or it may be something as simple as a mechanical problem. A valve positioner by definition has a linkage that connects to the valve stem. If that linkage should break, a little like the linkage on the accelerator of our motor car, if we're driving down the road and in the situation where we may have a breakage, with a motor car, of course, it just stops and we're parked on the side of the road. But it can be very inconvenient at 2 o'clock in the morning when it's pouring down with rain and we want to get home to our family. In a plant situation, if that valve linkage breaks, that valve will continue to travel in the direction it was last travelling in a standard valve positioner. It will not know that it's got a failure, so it will not go to a fail closed or fail open situation. It will go to the last position, it will then saturate, and then it will start to drive up and down. But the bottom line is we've lost control of the plant and we've shut the plant down. These intelligent devices can change their personality online. What that would do is allow the device to operate as an I2P, continue to operate. So if this happened at 2 or 2:30 in the morning, it would allow the valve to continue to operate, so be it maybe at 95% efficiency. But would we rather have that valve operating at 95% efficiency and reported specifically of the 500 valves, it's this very valve, and we've lost the feedback arm? The scenario is dramatically different, as we can understand. One, the plant shut down, and the other scenario where we have this predictive diagnostic feature, you can continue to keep the plant running and tell the person exactly what they need to do to fix the problem. The value of that in maintaining the plant operation can be millions of dollars. Thank you.
Tom, from what I understand, this is the last question. So, Georgia, is there anyone else that has a question? I'm happy to hold on if there is any other question there.
We've just had another one come through. Will wireless instruments eliminate the need of power supply, normally 24V and signal?
Thank you for that. So the question is, will wireless devices avoid the need to have power, 24 volts or a 4 to 20 milliamp signal? Again, it's one of those yes and no answers, and I'll be specific with that. If the device is fully wireless, that is, it has no wires, it has its own power module, then the answer is absolutely yes. And there are a large number of devices today now being manufactured that are self-powered, and that means that there will be no electrical cables either for the signal or for power. And those particular batteries, the Emerson battery is intrinsically safe, IEC-EX for zone 0, and can be installed in the zone 0 area. So yes, to get your instrument up and running, all you need to do is mount the instrument, put the battery, we call it a power module. The reason we use the terminology power module is because it is an intrinsically safe battery. That's installed and you're up and running. However, in many devices, the device may already exist and you want to get those valuable diagnostics out of it. That's often the case. The device exists. And you may have either 24 volts there or you may have a 4 to 20 milliamp signal. Installing the thumb means that you can get access to those diagnostics, and it uses the existing 24 volt or 4 to 20 milliamp loop. So it scavenges a very, very small amount of power off the 4 to 20 milliamp loop in the form of a voltage drop without affecting the 4 to 20 milliamp loop performance at all. And that device is suitable for installing in standard applications or in SIL 3 applications, and is Exeter certified for SIL rated applications. Thank you.
Georgia and Tom, are you all okay if I asked one more question? And how do you feel? Could you just perhaps a quick yes or no? If Tom, you are short of time?
No, I'm good, thank you.
Okay. A question that I have
I'm good, thank you.
Thanks, man. The question I have is, if wireless technology relies on devices that are detached, so to speak, there is a real pilferage problem with things like mobiles. Now, if wireless devices are detachable, and if one wireless device relies on a series of them to work as a combination, is plant pilferage a real issue? And through plant pilferage, I guess interruptions in plant operability an issue?
An excellent question. In all of my years in automation, I can't think of an instance where somebody's come along and stolen a transmitter where it's already physically wired up. However, I can imagine that that would happen. So it would be very easy to, the connection of the transmitter for most part is identical to the wired transmitter in a mechanical sense. So if it's a temperature transmitter, or one of the last ones we saw, which was the hydrocarbon sensor, the transmitter is bolted with a classic 2-inch instrument pipe mount. So, you know, if somebody came along with a spanner and undid the bolts and then undid the cables, they could take away a conventional wired transmitter, The wireless transmitter, again, they would have to need a spanner. They would need a spanner rather, and they would have to come along and undo those bolts to be able to get the transmitter off the pipe stand. And I guess that's probably 90% of the time. Taking the cover off and undoing the two screws is very simple. In a wireless world, the difference is very, very small. It is, of course, quite practical to get locking devices to lock that device to the pipework if that was a problem, but I don't foresee that being the situation. We have 2 or 3 applications, one in Wellington in New Zealand, right across from the Beehive. People may recognise that. That's the Parliament House, where they need to measure flow in a street, in a pipeline in the street. It's in a well. And we will end up having one repeater about 200 metres down the track, and that's going to be bolted onto a lamppost. So in that situation, we've recommended that the customer just put it in a small grey, inconspicuous plastic box that's bolted to a pole, and just mount the instrument inside that. The instrument will work perfectly well inside a plastic box, and it's just out of sight, out of mind. Thank you.
Okay, I think we're just about finishing up now. I'd like to thank Tom for presenting the webinar.
Georgia, could I perhaps also put a quick word in myself? Thank you.
Sure.
Gentlemen, could I thank Tom, and I just wanted to actually take our minds back to how phones used to be with a wire connected to the phone. I guess if we had this discussion on mobile phone technology, 12 years back, and said this is, I guess, the future of how phones would be going, I sort of sense that this is at the cusp of where, I guess, plant asset management technology could go, and we've seen the progress of mobile phones over I guess the traditional phones, so it's certainly an area of strong interest, and I'm sure the community will be following that keenly. I guess having said that, I'd like to thank Tom for the presentation. I'd like to thank the participants, and perhaps if there's any feedback that Systenergy can take on board in terms of how to improve this in the future, please do let us know as well. Thank you, Georgia. Thank you, Tom, and thank you for participating. Bye-bye.